In this Huberman Lab podcast episode, Andrew Huberman focuses on alcohol consumption and its effects. The episode covers various aspects, including the impact of alcohol on our biology, both at the cellular and organ level, as well as its influence on our behavior and thinking when intoxicated. The discussion also delves into the question of whether low to moderate alcohol consumption is healthier than abstaining entirely, and addresses topics like binge drinking and hangovers. Genetic differences related to alcohol and alcoholism, the dangers of alcohol consumption in young people, and resources for those seeking help with excessive alcohol consumption are also explored. The goal is to provide listeners with comprehensive knowledge about alcohol's effects on the brain and body so they can make informed decisions about their alcohol consumption without judgment. Andrew Huberman addresses a frequently asked question about alcohol consumption and its impact on the brain. Specifically, he explores whether low to moderate alcohol intake, such as 1 or 2 drinks per day, contributes to neuronal degeneration. Huberman notes that high levels of alcohol consumption have long been associated with neurodegeneration, particularly affecting the neocortex, which is responsible for functions like associative memories, planning, and impulse regulation. Huberman refers to a recent study called Associations Between Alcohol Consumption and Gray and White Matter Volumes in the UK Biobank, which examined the brains of over 30,000 generally healthy middle-aged and older adults in the United Kingdom who consumed varying amounts of alcohol. The study revealed that even individuals consuming low to moderate amounts of alcohol exhibited thinning of the neocortex and other brain regions, indicating neuronal loss. He emphasizes that the study's findings are important because they address whether chronic alcohol intake, even at relatively low levels, can negatively affect the brain. Huberman defines chronic as an average consumption of 1 or 2 drinks per night or day, translating to 7 to 14 drinks per week. This study implies that even those consuming as little as 7 drinks per week may experience some degree of brain degeneration due to alcohol intake. However, he suggests that later, they will discuss strategies that might mitigate such neuronal loss. Huberman provides a link to the detailed study in the show notes for those interested in further exploration. Andrew delves into the history and properties of alcohol. He acknowledges that humans have been consuming alcohol for millennia and mentions archaeological evidence dating back 5,000 years to wine vessels in Mesopotamia. Huberman dispels a common misconception by stating that distillation didn't originate in Ireland. It was first practiced in China during the 1st century. He highlights various uses of alcohol, including for nutritional, medicinal, cleaning, and laboratory purposes. The discussion then focuses on the pursuit of altered states of consciousness induced by alcohol, despite its tendency to make individuals feel less happy, motivated, and more stressed once the effects wear off. Huberman clarifies that he's not demonizing alcohol, but aims to explain what it is, how it affects the body, and the potential consequences of even occasional or moderate consumption. Huberman explains the basic chemistry and biology of alcohol, emphasizing its water and fat-soluble properties, allowing it to enter cells and organs easily, which contributes to its damaging effects. He notes that there are 3 main types of alcohol, but only ethyl alcohol, ethanol, is fit for human consumption, albeit still toxic. When ethanol is ingested, it undergoes conversion in the body, involving molecules like NAD, nicotinamide adenine dinucleotide, and acetaldehyde, a highly toxic substance. This conversion, occurring mainly in the liver, generates acetate, which can be used as fuel but lacks nutritional value. Alcohol is considered empty calories due to its metabolically costly nature and absence of essential nutrients. Huberman provides insights into the metabolic process of alcohol and its implications for health. Andrew then explains how alcohol affects the brain and behavior. He emphasizes that the feeling of being drunk is essentially a disruption caused by acetaldehyde, the toxic compound produced during alcohol metabolism. Alcohol affects various neural circuits, brain areas, and body functions. When people consume alcohol regularly or have a genetic predisposition to alcoholism, they tend to experience increased alertness and mood for longer periods compared to occasional drinkers. This distinction in alcohol's effects can predict the risk of alcoholism. Chronic or regular drinkers often exhibit heightened energy and sociability when they drink, while occasional drinkers have shorter-lived positive effects. Alcohol's journey in the body involves its conversion from ethanol to acetaldehyde to acetate, with some acetaldehyde and acetate reaching the brain by crossing the blood-brain barrier. These compounds interact with different brain areas, including the prefrontal cortex. The prefrontal cortex's suppression leads to increased impulsivity, motor skills decline, and speech volume elevation, typical effects seen at social gatherings with alcohol. Furthermore, Huberman reveals that habitual and impulsive behavior circuits in the brain are altered by regular alcohol consumption. Even individuals who drink moderately but consistently, for example, every Thursday or Friday, experience changes in neural circuits that make them more habitual and impulsive both during and outside of drinking episodes. These alterations involve an increase in synaptic connections for habit execution and a reduction in synaptic connections for behavior control. However, these changes can be reversed through abstinence, typically over 2 to 6 months, with long-lasting impacts occurring mainly in cases of heavy, long-term alcohol use. He then delves deeper into the neurochemical effects of alcohol, particularly focusing on individuals who consume 1 or 2 drinks per night on average. He clarifies that the impact of alcohol varies based on factors like body weight, tolerance, genetic background, and whether one has eaten. Addressing the common misconception that eating can sober someone up once they are drunk, Huberman explains that eating before or during alcohol consumption primarily slows down the absorption of alcohol into the bloodstream. This delay is most effective when a meal includes carbohydrates, fats, and proteins. However, once alcohol is already in the bloodstream, eating will not accelerate the process of sobriety, but can mitigate the effects of additional alcohol intake. Huberman then discusses the neurochemical effects of alcohol on serotonin, a neuromodulator involved in mood regulation. He references recent research that suggests serotonin levels alone do not explain depression. He clarifies that while selective serotonin reuptake inhibitors, SSRIs like Prozac, increase serotonin levels, they likely alleviate depression by reshaping neural circuits rather than directly altering serotonin levels. Moving on to the effects of alcohol on serotonin, Huberman reveals that acetaldehyde, a byproduct of alcohol metabolism, disrupts serotonin-related neural circuits, initially leading to increased mood and talkativeness. As people continue to drink, serotonin levels and circuit activity drop, causing a decrease in mood. People often attempt to restore this mood by having more drinks, but this strategy is rarely effective. Interestingly, Huberman notes that some individuals experience heightened alertness and mood as they consume more alcohol, which might indicate a genetic predisposition to alcoholism or chronic drinking. He also emphasizes that chronic drinkers, especially those with specific genetic factors, can tolerate and even benefit from higher alcohol consumption, experiencing a surge in energy and sociability before eventually passing out. Huberman highlights the phenomenon of blacking out, wherein individuals drink heavily, engage in various activities, yet have no memory of these events due to the suppression of hippocampal neurons responsible for memory formation. He cautions that recurrent blackouts should be taken seriously, as they can be indicative of a higher risk for developing alcoholism. Andrew then discusses key factors that can indicate a predisposition to alcoholism. He clarifies that when people consume alcohol, they can generally be categorized into 2 groups: those who start feeling sedated after a few drinks, and those who do not. This categorization can predict whether someone has a predisposition for alcoholism. Huberman highlights the impact of alcohol on the hypothalamic pituitary adrenal (HPA) axis, which regulates stress responses. Regular alcohol consumption, even in moderate amounts, can lead to increased cortisol, stress hormone, release when individuals are not drinking. Consequently, these individuals often experience higher stress levels and anxiety during sober periods. He emphasizes that these changes in neural circuits and hormonal balance persist long after drinking episodes, potentially leading to increased stress and lower mood when not drinking. Huberman stresses that while he does not intend to demonize alcohol, it's essential to recognize that chronic alcohol consumption, even at common levels, can result in these long-term negative effects. Huberman also touches on genetic predispositions to alcoholism, explaining that multiple genes related to serotonin and GABA receptors, as well as the HPA axis, interact with environmental factors to influence alcohol use disorders. While there isn't a single alcoholism gene, having immediate family members with alcohol issues increases the risk. Moreover, he highlights that the age at which individuals start drinking significantly influences the likelihood of developing alcohol use disorder, with those starting later having a lower risk. Huberman then talks about the detrimental effects of alcohol consumption, particularly in the context of chronic or moderate drinking patterns. He starts by acknowledging that occasional moderate alcohol consumption is generally not harmful for most adults. However, Huberman delves into the negative impact of alcohol on the gut-brain axis, specifically the gut-liver-brain axis. Alcohol disrupts this axis in several ways. Firstly, it indiscriminately kills both beneficial and harmful gut bacteria, disrupting the gut microbiome that plays a crucial role in supporting the immune system and regulating mood through neural and chemical signaling. Secondly, alcohol metabolism in the liver leads to the release of pro-inflammatory molecules like cytokines, contributing to various health issues. This combination of gut microbiota disruption and inflammation can result in a condition known as leaky gut, where bad bacteria and partially digested food can enter the bloodstream. Furthermore, the inflammatory signals generated by alcohol consumption can reach the brain through neuroimmune pathways. This disruption can lead to increased alcohol consumption by interfering with the neural circuits that regulate alcohol intake. Huberman emphasizes the concerning feedback loop, where alcohol exacerbates gut and brain issues, leading to further alcohol consumption. However, he also discusses potential strategies for mitigating the harm caused by alcohol. He suggests incorporating 2 to 4 servings of low-sugar fermented foods per day, such as kimchi or sauerkraut, as they may help reduce inflammation and improve the gut microbiome. While these strategies haven't been specifically studied in the context of alcohol use disorder, they hold promise for supporting gut health and reducing inflammation. Finally, Huberman highlights the importance of being prepared for increased stress and anxiety when attempting to reduce or quit alcohol. Chronic alcohol consumption can alter cortisol levels, making stress management techniques crucial during this process. He suggests referring to resources on mastering stress for effective stress control strategies. Andrew talks about the phenomenon of hangovers, post-alcohol consumption malaise. He begins by explaining the various components of hangovers, such as headaches, nausea, and hangxiety, anxiety following alcohol consumption. He connects hangxiety to alcohol's impact on cortisol levels, leading to increased stress hormones. Huberman emphasizes that the quality of sleep after alcohol consumption is poor. Alcohol disrupts sleep architecture, affecting deep sleep and rapid eye movement, REM sleep, which are essential for restorative sleep. Hangovers typically result from consuming more than a moderate amount of alcohol, leading to disrupted sleep. He delves into the role of the gut microbiome, explaining how alcohol destroys healthy gut bacteria, leading to leaky gut and potential discomfort. Huberman suggests that consuming low-sugar fermented foods, probiotics, or prebiotics could help restore gut health. Hangovers often include symptoms like stomach aches, headaches, and fogginess. Huberman clarifies that these symptoms can be related to disrupted sleep, gut microbiome issues, and vasoconstriction, narrowing of blood vessels, following alcohol consumption. He warns against using non-steroidal anti-inflammatory drugs, NSAIDs, like aspirin to alleviate hangover symptoms, as they can have adverse effects on the liver and gut microbiome, which are already strained by alcohol metabolism. Huberman explores the idea of using deliberate cold exposure, such as cold showers, to relieve hangovers. He explains that cold exposure can spike adrenaline and dopamine levels, potentially aiding alcohol clearance. However, he stresses the importance of safety when considering this approach. Furthermore, he addresses dehydration caused by alcohol's diuretic effect. Alcohol can disrupt the body's water balance and electrolytes, leading to hangover symptoms. Huberman recommends drinking water with electrolytes before, during, and after alcohol consumption to mitigate these effects. Continuing with the discussion, Huberman goes on to talk about alcohol tolerance and its impact on the brain. He simplifies the concept of tolerance by explaining that it refers to the reduced effects of alcohol with repeated exposure. This phenomenon is primarily caused by changes in neurotransmitter systems in the brain, resulting from the toxic effects of acetaldehyde, a byproduct of alcohol metabolism. Huberman emphasizes the pleasure-pain balance associated with alcohol consumption. Initially, when people start drinking, there is an increase in dopamine and serotonin levels, leading to a sense of well-being and mood enhancement. However, this positive effect is short-lived. Following this initial boost, there is a gradual and prolonged reduction in dopamine, serotonin, and related molecules. This creates an overall feeling of discomfort and malaise, prompting individuals to continue drinking to recapture that initial euphoria. The key insight into tolerance is that, with repeated drinking, this unpleasant phase after the initial high becomes even longer and more pronounced. The more someone drinks, the less they experience the pleasurable effects, and the more they suffer from the negative consequences of alcohol. This cycle can lead to an increase in alcohol dehydrogenase, the enzyme responsible for metabolizing alcohol, which contributes to the body's efforts to process the excess alcohol. Huberman suggests that if you notice you need to consume more alcohol to achieve the desired effect, you are likely disrupting the dopamine and serotonin systems in your brain, which results in prolonged discomfort and negative feelings following alcohol ingestion. He also briefly mentions the potential health benefits of substances like Resveratrol found in red wine. While some studies suggest potential benefits from low to moderate red wine consumption, the amount required to gain significant health benefits is so high that it could lead to other harmful effects from alcohol consumption, offsetting any potential advantages. Huberman discusses the relationship between alcohol consumption and its impact on brain health, particularly the reduction in cortical thickness. He points out that various studies have shown that alcohol consumption, even in light to moderate amounts, can lead to a decrease in cortical thickness, and this reduction is directly proportional to the quantity of alcohol consumed. Moreover, he underscores the severe health risks associated with alcohol consumption. Alcohol, due to its toxicity, particularly the acetaldehyde it produces during metabolism, can alter DNA methylation and gene expression. This alteration in gene regulation is linked to a significant increase in cancer risk, especially breast cancer. Studies have suggested a 4 to 13% increase in breast cancer risk for every 10 grams of alcohol consumed daily. Huberman also clarifies the concept of alcohol equivalents across different countries, noting that the size and alcohol content of drinks can vary widely. In Japan, 1 beer, 1 glass of wine, or 1 shot of liquor typically contains 7 to 8 grams of alcohol. In the US, these drinks typically contain 10 to 12 grams of alcohol, while in Russia, a single drink can have as much as 24 grams of alcohol. To put these numbers into perspective, Huberman draws an alarming parallel between alcohol consumption and smoking, suggesting that 10 to 15 grams of alcohol daily, equivalent to 1 drink in the US, can be as harmful as smoking 10 cigarettes a day. He acknowledges that while the comparison may not be perfect, there is a consensus in the scientific community that both alcohol and smoking carry substantial health risks. Despite these risks, Huberman offers a glimmer of hope. He mentions that consuming adequate amounts of folate and other B vitamins, especially B12, might partially offset some of the increased cancer risk associated with alcohol consumption. These vitamins play a role in gene regulation pathways related to tumor growth. However, he emphasizes that this is not a guarantee against cancer, and that the best approach to mitigating alcohol-related health risks is moderation or abstinence. Huberman's discussion serves as a cautionary reminder of the potential health consequences of alcohol consumption, even in moderate amounts, and the importance of making informed choices regarding alcohol consumption and its potential effects on health. In the final part of the episode, Huberman addresses specific concerns related to alcohol consumption. He highlights the critical point that pregnant individuals should absolutely avoid alcohol consumption due to the well-established risk of fetal alcohol syndrome. Fetal alcohol syndrome can lead to severe and permanent developmental issues in fetuses, affecting brain, limb, and organ development. Huberman emphasizes that there is no safe type of alcohol during pregnancy. All forms of alcohol pose a risk to the developing fetus because alcohol is a toxin that can disrupt crucial cellular processes during embryonic development. Next, Huberman delves into the effects of alcohol on hormones, specifically testosterone and estrogen. He notes that alcohol, particularly its toxic metabolites, can increase the conversion of testosterone to estrogen. This conversion can occur in various tissues in both males and females, affecting aspects such as libido, sexual development, memory, cognition, and more. In females, this can contribute to an increased risk of estrogen-related cancers like breast cancer. In males, it can lead to conditions like gynecomastia, breast tissue growth, diminished sex drive, and altered body composition. Huberman acknowledges that the research on alcohol's effects on hormones can be complex, with some studies suggesting acute alcohol intake may increase testosterone temporarily. However, he emphasizes that chronic alcohol consumption is more likely to disrupt the testosterone to estrogen ratio, which can have detrimental effects. Therefore, he recommends avoiding excessive alcohol consumption to maintain hormonal balance. Throughout the episode, Huberman provides a balanced perspective on the effects of alcohol, emphasizing that he is not here to dictate behavior, but to inform listeners about the potential health risks associated with alcohol consumption. He encourages individuals who choose to consume alcohol to consider the documented negative effects and explore tools and strategies, both behavioral and otherwise, to offset these effects and promote overall health. Huberman's aim is to empower individuals with knowledge to make informed decisions about their alcohol consumption and its potential impact on their well-being. Thank you all for tuning in to DM Podcast Takeaways. If you found this summary insightful, please consider subscribing to our channel for more engaging content. We'd also love to hear your thoughts, so please don't hesitate to leave your comments and questions below. Your feedback is invaluable in shaping the future of our content. Stay tuned for more exciting discussions and takeaways.